a liquid once worshipped by emperors, believed to unlock the secret of immortality. Ancient rulers consumed it, trusting it would extend their lives forever. But in reality, this shimmering substance is one of the most toxic materials known to humanity. This is mercury, the only metal that naturally exists in liquid form at room temperature. It looks mesmerizing, almost magical, flowing like silver water. Yet beneath that beauty lies a silent danger capable of destroying the human nervous system. Today we journey deep underground to uncover how this silver monster is mined, processed, and transformed into something people once trusted inside their homes. Mercury doesn't flow freely underground. Instead, it is locked inside a striking red mineral known as cinnabar, or mercury sulfide. Deep beneath the Earth's surface, miners navigate tight, hazardous tunnels where oxygen is limited and temperatures can rise quickly. Using powerful pneumatic drills, they bore into solid rock, searching for veins of cinnabar. Carefully controlled explosions then break apart the ore without collapsing the surrounding structure. Every step is dangerous, not only because of falling rock, but also due to invisible mercury vapors that may already be present. Extracting this red ore is the first step in unlocking one of the world's most unusual and dangerous elements. Once the cinnabar ore reaches the surface, it is transported to industrial processing facilities. Massive crushing machines break the ore into smaller fragments, increasing the surface area for the next stage. These fine particles are then fed into large rotating furnaces known as rotary kilns. Inside, temperatures soar to about 840 degrees Fahrenheit or 450 degrees Celsius. At this point, a remarkable transformation occurs. The mercury within the cinnabar doesn't simply melt, it vaporizes. The intense heat breaks the chemical bond between mercury and sulfur, releasing mercury as a toxic gas. Within minutes, most of the metal is freed from the ore. The toxic mercury vapor released during roasting must be handled with extreme care. It is directed through a network of sealed pipes into specialized cooling systems. Here, temperatures are rapidly reduced, causing the vapor to condense back into liquid form. This liquid mercury is collected in secure containers, often reaching purity levels of up to 99.9%. For applications requiring even higher precision, the mercury undergoes multiple distillation cycles. Each cycle involves evaporating and condensing the metal again, removing even the smallest impurities. This careful process ensures the mercury meets strict industrial and scientific standards without releasing harmful fumes into the environment. Despite its fascinating properties, mercury remains extremely dangerous. One of the most tragic examples is the Minamata disaster in Japan, where industrial mercury pollution contaminated water and poisoned thousands of people. Victims suffered devastating health effects, including birth defects and paralysis. Because of these risks, modern facilities enforce strict safety protocols, including sealed systems, continuous air monitoring, and advanced filtration technologies to protect both workers and the environment. For many years, mercury played an important role in everyday tools, especially thermometers. Inside a narrow glass tube, mercury responds quickly to temperature changes. As heat increases, the liquid expands and rises smoothly along the scale. When cooled, it contracts and falls back down. This consistent and precise behavior made mercury ideal for accurate temperature measurement. It was widely used in homes, hospitals, and laboratories around the world. However, due to its toxicity, many countries are now phasing out mercury thermometers, replacing them with safer digital or alcohol-based alternatives that eliminate the risk of harmful exposure. Mercury thermometers would not exist without glass, a material just as fascinating in its own way. Glass begins as silica sand, one of the most abundant materials on Earth. This sand is heated to extreme temperatures above 1,600 degrees Celsius until it melts into a glowing, molten liquid. Skilled processes then shape this liquid into tubes, containers, or sheets. As it cools, it becomes the solid, transparent material we recognize as glass. From simple bottles to advanced smartphone screens, glass plays a critical role in modern life, perfectly complementing mercury in precision instruments like traditional thermometers. From a deadly red mineral buried deep underground to a liquid metal once trusted in our homes, mercury tells a powerful story of human curiosity and innovation. It shows how something beautiful can also be dangerously deceptive. While science has allowed us to harness its unique properties, it has also revealed the serious risks it carries. Today, as we move towards safer alternatives, mercury serves as a reminder that progress must always be balanced with responsibility. So here's the question. When something is this dangerous, should we continue using it, or is it time to leave it behind for good?